Good evening, everyone. Well, don't worry. The previous meeting was on till 4:08 or something, so that's why it got late. Don't worry. I was not going to leave anyone out. Okay, so I think we can start now. Uh, so yesterday we talked about this dipole and its electric potential. Harshad, we were to start with your question. We will not carry on a bit longer, of course. Okay. Harshad, what was your question? Are you ready with it solved? Okay, no problem. Fine, then we can continue with this, right? Okay, so we derived this formula of potential due to electric dipole. All right. You can see that this is not, this is not following the usual thing for a point charge. For a point charge, you have E proportional to 1 by r square, and you have V proportional to 1 by r. But now for a dipole, we had for far away points 1 E proportional to 1 by r cube, and here we have V proportional to 1 by r square, right? So it's slightly different. Okay. All right. Well done. So now that is it about dipole. Now I'm going to ask you a question. All right. So that everyone gets a chance to practice their knowledge. Okay. So let's say that this is a dipole. All right. With charge magnitude Q equal to 10 raised to minus 9 coulomb. All right. And if we take 4 points. Okay, let me also put the distance between these two. Suppose the distance between these two is 1 angstrom. Okay, 1 angstrom. I hope everyone remembers what is 1 angstrom, right? And if I take 4 points, C at the center of this dipole, okay, right? B over here, all right, at a distance of 1 meter, okay, and A over here at a distance of 1 meter, and D over here at a distance of 1 meter. Okay. So then you have to find potential. You have to find potentials, right? You have to find V at every point and arrange in increasing order. Okay. You arrange the potential of these 4 points A, B, C, D in increasing order. C is the midpoint, of course. Okay. Do it. Come on. I hope everyone has started. These are 4 points, and you have to put it in increasing order of potential. No, Avinash, not at all. Don't forget the formula that we derived was for which case? Chaitya, think about your answer a little bit. In increasing order. Hmm. Okay, very good. People are trying. Hmm. Are you sure, Ritwa? Think about what you have done. Jia, how can VB equal to VC? No, Chaitya, that reason is definitely wrong. Potential increase, electric field decrease is not valid, right? There is no such relation between them. B less than D less than A less than C. No. Mega, no, not the right answer. I think I have not I've not got any correct answer yet. No, VB is not equal to VD. No way. Okay, let me do it. A then B equal to D and then C. No. VA equal to VC. That is correct. Well done. VA is equal to VC. C greater than D. No. No. B less than C less than A less than D. No. K, you got the right answer. Very good. No, Darshi, that's not right. Dhawal, no, not correct. VB is less than VD, that is right. VA is equal to VC. Srishti, which is less, 0 or negative? No, Sakshi, wrong answer. Okay, fine. Let's do it. Now, first of all, C is midpoint. Okay, so at that point we see the potential due to due to the charges. No. Okay, VC is equal to VC due to positive charge plus VC due to negative charge. Both of them are at same distance, right? Both of them are at same distance. That's why this is going to be KQ by R and this is going to be K minus Q by R because distance is same. So VC is equal to 0 first of all. Okay, VC is equal to 0. Now, the next thing. Here A is at right angle to this dipole, okay? So, and it is at far distance, isn't it? 1 meter. Isn't 1 meter much greater than 1 angstrom, right? So we can use the formula. What's the formula? Potential at any point due to dipole is Kp cos theta divided by r square, right? But if you look at this diagram carefully again, A is here. So this angle is 90. So theta is 90, right? So that's why this is also 0. Potential at A is also 0. So we have VA is equal to VC. Now we go to B and D. Both of these are 0, right? Now we go to B and D. Actually, if you want to find it for B and D, you can do it using formula. But right now it is only about increasing order. Then obviously D is on positive side, right? D is on the positive side. It's close to the positive charge. That's why potential at D will be positive, right? Potential at D is positive, right, greater than 0. But potential at B, which is on the negative side over here, close to the negative charge, right, that's why the potential at B is negative, right? I'm not finding the value. You can find the value if you want. There's nothing wrong with it. You just have to use this Kp cos theta by r square formula, because r is much greater than A, right? So that's how finally we get this order. Both of these are 0, VB is less than 0 and VD is greater than 0. So that's why negative comes first in increasing order. So VB, then VA, which is equal to VC, and then VD, right? This is the correct answer. Ask questions if you have any. Come on. Any questions, people? Sarete, how is it resultant vector? We don't have to find resultant vector, Chaitya. Potential is a scalar, not a vector. So Krupa, you understood that? No questions, anyone? Yes, A, the formula, this formula, we derived the formula, right? Put everything in the formula. Theta is 90, cos 90 is 0, done. Didn't understand VC equal to A. Did you understand VA is 0? And did you understand that VC is 0? If both are 0, both are equal, simple. If B and D was on one side, then we'll have to look at the distance, right? Okay. Two forces are not applied. This question was not about force, Chaitya. This question was about potential. All right. So read the question carefully. Okay. All right. Now, I think we can solve some textbook question based on this, right? Okay. You are in 12th standard. Okay. Let's go to the exercise. All right. We are going to the exercise and we are going to solve question number 12. Okay, we are going to solve question number 12. It is from additional, but it's very interesting. Let's do that. Start reading the question, everyone. Okay, now what's given? We are going to draw a diagram regarding this, right? A charge of 8 millicoulomb is located at origin. Okay, so we are going to place some charge at origin, Q, and Q is 8 millicoulomb. Calculate work done in taking a small charge. Okay, so sorry, I'm going to change the symbol. Let's call this capital Q, right? And now we are given another small charge, minus 2 into 10 raised to minus 9 coulomb, from a point 003 centimeter, right? So it is in 3D, right? Don't worry too much about the 3D actually in this question. It's fine. I'm drawing it as best as I can, right? Here is that charge at this point P. What are the coordinates of P? 0, 0, 3 centimeter, right? So this is on Z axis. From there, we have to take this to Q, this point Q. Okay, where is that point Q? At 0, comma 4 centimeter, comma 0. So first here, from here we take it there, and then, no, sorry, we have to take it to Q via a point R. Via means through. So first, we don't have to go directly over there. We have to go to 0, comma 6, comma 9, right? So let's say that's somewhere here in space, all right? So this is 0, comma 6, comma 9. That does not change the question, no. Okay, again, I'm saying that it is given that there's a small charge here at P. We take it from P to Q, right? We take it from P to this point Q, which is 0, comma 4, comma 0, but via R. So first we take it there, and then we take it there, right? 2 steps. Correct. So now we have to find work done in taking a small charge from this to this. See, there's always going to be a mystery. This is work done by whom? That is not mentioned, right? Is it work done by electric field? I don't know, right? We will assume work done external, all right? External work done. See, we solved a question like this earlier. I hope you remember that we just have to find the delta U, right? Because external work done is delta U. And because electrostatic force is conservative, path does not matter, right? Work does not depend on path, right? So you don't have to worry about going from P to R. Yeah, you can do that, Tanay, no problem, right? As path does not matter, so instead of going from P to R to Q, we can just say P to Q. Okay, no problem, because path does not matter. Only initial and final points matter. So this is delta U. So small charge Q, right? Or you could also say potential energy of two charges is K, Q1, Q2 by R, right? Okay, yes or no? Is everyone okay with this formula? Fine, fine. So you could use that, right? U2 minus U1, okay, final minus initial, right? So final, K, capital Q, small q divided by distance. Can you tell me what is the final distance between the charges, right? Which charge is capital Q and small q? What's the final distance between the charges? What's the final distance between the charges? Some of you said 5. Are you sure? 5 centimeter? How on earth did you get 5? Yes, Suraj, you can do that. આપણે એ જ કરીએ છીએ, આ સેમ જ છે. ડેલ્ટા યુ ઇક્વલ ટુ ક્યુ ડેલ્ટા વી એ જ છે. 10 centimeter, no way. People don't get confused. When you write the potential energy formula, R stands for distance between charges, not for distance traveled or displacement, right? R stands for distance between charges. So at the final position, distance between 040 and origin, how much is the distance between 040 and origin? It's obviously 4 centimeter, right? So kq by 4 centimeter. All right, there were many who did it wrong. Okay, please be careful, people. Tanas, Terim, Srishti, Sanket, Krupa, Jai, Vishwa, come on, people. I hope you understood that. Vivek, Purvendra, yeah, okay. Do you want me to explain it again, people? See, just like it was in gravitation, G m1 m2 by r with a minus sign. What does r mean? Distance between masses. Just like that here, r means distance between charges, right? Not distance traveled or not displacement. Finally, this charge q is here, and this capital Q is at origin. How much is the distance between 040 and origin 000? Obviously 4, right? Why are you worrying about this right now? Clear? Okay, fine. Minus. Now you have to tell me what should I be writing? KQQ by what? Initial. Come on, initial. Hurry up, hurry up, hurry up. Everyone, hurry up. That's right. 3 centimeter. Very good. 3 centimeter. Right. Now, what's common? KQQ is common, right? And instead of centimeter, you could write 1 upon 100 for converting it to meter. So this will become 1 by 4 minus 1 by 3. Let's put values now. Okay, let's put values. So K is 9 into 10 raised to 9. Charge Q, what is charge Q? Capital Q is 8 millicoulomb. Okay, 8 into 10 raised to 3. Charge small q is negative 2 into 10 raised to 9 minus 9. Okay, into 1 by 4 minus 1 by 3 is minus 1 by 12. Okay, I took LCM, right? And 100 is remaining. 100. Ramya, answer is negative or positive? Raj, is the answer negative or positive? Think about it. Plus 1.2 or minus 1.2? Uh-oh. Just give me a minute. Hmm. Right. So the final answer to this question will be 1.2 into 10 raised to, no, sorry, only 1.2 joule, right? So how can the answer be negative? I don't understand. I hope it is clear to everyone that the answer is positive. Screen is not available. Just a minute. Huh? I'm so sorry. I did something that seems to have closed the screen. I'm so sorry. Okay. Did you check the answer at the back? Did you check the answer at the back? It's 1.2 or minus 1.2. Is the answer at the back 1.2 or minus 1? Oh, so that means it's work done by external something, okay? Right? It is not given in the question, we just guessed it, very frankly. All right, now let's go to the next question that we can do from this exercise. Okay. I think I can give you two questions for homework. 13 and 14 are homework. All right, let me write it to everyone. 13 and 14 homework. Okay, make sure you do it. Now, I think there's not much here really. Okay, so we'll go to the next topic, right, in the time that we have, that I believe is equipotential surface. No, we have an example. Sorry, there's an example which we could do. I remember now. We are going to example 3. Example 2 is homework, and we are going to example 3. We did a question yesterday. This example 2 is just like that. Okay, and we now do example 3. Come on. This is a very good question from concepts point of view. All right, there's no calculation. Joy, I think we'll keep that for some time later, right? Let everyone get used to this when I don't have anything ready over here at home, right? Okay. So here is this question. All right. Example 2.3. Figure show field lines of a positive and negative charge respectively. Okay. Right. Thank you for telling us. This is for those who didn't pay attention in the first chapter. Right. Now, give the signs of potential difference Vp minus Vq and Vb minus Va. Okay. See, give sign means we have to see whether it's positive, negative, or zero, right? Okay. So we just have to check which is more, right? If Vp is more, it's positive. right? If Vp is more than Vq, then Vp minus Vq is positive. Otherwise, it is negative, like that. Okay. So let's start. Now, have a look at this positive charge, right? Okay. Both negative. What does that mean? Okay, you mean to say Vp minus Vq and Vb minus Va both are negative? No, 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 no. Okay, let's take it stepwise, right? Don't rush. Okay, many of you have started answering. That is good. તો આ કરાવવાની જરૂર નથી લાગતી હવે, બધાને આવડે જ છે, ખાલી મને જ નથી આવડતું. હા, બરાબર. Both are positive depending on distance. Okay, fine. Now let me try. Let me try. See, because first we'll talk about A only, all right? Forget about B. So for A, this charge is positive, right? So potential is kq by r, but because numerator is positive, as r will increase, as distance will increase, v will decrease, correct? So that's why Vp is greater than Vq. Okay, fine. So that means Vp minus Vq is greater than 0, positive. So that's it. So many of you gave the right answer. Well done. Now we will try similar for B. Okay. For B, you have this charge as negative. So it's V is equal to K minus Q by R, right? Some negative charge. Okay. That's why I'm writing minus Q. Okay, Hitansh, first will be positive, second is negative. He's saying V minus V is positive. Okay. Let's see. So this is what we have, right, for a second. Now see, this is a negative number. Like, let's put minus 10 over here. Okay. Suppose this was numerator minus 10, right? Now if I put small distance, suppose I'll put r equal to 1, then v will be minus 10. But if I'll put r equal to 2, means larger distance, then v will be minus 5, right? Okay. So this is closer point is A and far point is B, right? So this is close and this is far. So which one has more potential? Far has more potential, right? So this is B and this is A. Clear? So we have VB is greater than VA, therefore VB minus VA is positive, right? So the answer to both of these is positive, right? Well done, people. So many of you gave the right answer. So many of you gave the right answer. Well done. Now, is there any question about this A? Is there any question about this one? If yes, ask right away. If not, I'll go over to a slightly different method, right? About, it's like we are talking about a relation between electric field lines and potential. Okay, no questions, I believe. Right. So here is a very important observation. I'm going to write that observation. It's like a very important sentence. You also write it in your notebook at the top. Okay. And remember it. It is that electric field lines point from a higher potential, actually electric field or field lines both, right? Electric field or field lines both point from higher potential towards lower potential. That is always true, right? This sentence can never be wrong. Okay, so please write this sentence in your notebook. Make sure you remember it. Okay, see, this is this is how it should be, because think of a positive charge q, right? And let's say in its field we put a small positive charge q, okay, another positive charge. Then both are going to repel, correct? Okay, both are going to repel, right? So this charge will go away on its own, right? You don't have to do anything. This charge will go away on its own. But sir, that is not correct. Potential does not depend on charge. V is independent of test charge. Don't forget that, right, Avinash? So your whatever you said is not true. So let's continue with what I was saying. If you consider this charge plus q and this plus q, okay, and they repel, so this will go away, right? Okay, that I'm sure you remember, whenever anything happens on its own, that is only possible if potential energy is decreasing, right? Okay, nature loves to decrease potential energy. So that is obviously due to the fact that if this q goes away, potential energy will decrease. But because this is positive, right, and v is equal to u by q, so if u will decrease and q is positive, so v will also decrease, right? So that's why for and you know that a positive charge will move in direction of field, right, in same direction as E vector. So that's why you can say that if potential is decreasing towards this right side, then electric field will be towards right side, like that. Similarly, if you put a charge here, then this will go towards left side. It will go away, because if it will go away, potential energy will decrease, right? Sir, we can't find electric potential at any single point charge. So you cannot find electric potential at this charge, right? It is infinite, or you should not do that. Okay, so this is the basic idea, right? Electric field lines point from higher potential to lower potential. If it was negative charge at the center like this, then you can see the field lines are coming in, right? Okay, so because the field lines are coming in, this point is at more potential and this point is at less potential. That's what we have seen. Now we go to B. Give sign of potential energy. See, this can be very confusing, right? Please take it very carefully. Read it. Please give the sign of potential energy difference. Give the sign of potential energy difference of small negative charge between points Q and P. Okay. Okay, so what do you have to find? I want to know what is your opinion. Do we have to find UQ minus UP or UP minus UQ? Answer that in the chat box. Come on, hurry up. Which one? First one. Okay. Fine. So most of you are saying UQ minus UP. All right. Okay. So now if you do it that way, okay. Avinash says second, right? It, it is always confusing, isn't it? Whenever someone says, find the difference between this and this, then you have to find it, which difference do you have to find? Generally, generally we tend to find between final and initial like this, right? Final minus initial. So if you go by that, it should be UP minus UQ. Okay, no problem. What we'll do is, we'll do it both ways, right? Our aim is to get the answer. So give the sign of potential energy difference. UQ minus, let's find UQ minus UP first. Okay, see what happens. Okay, let's find UQ minus UP for a small negative charge between points P and Q. Okay, so, okay, solution has started. Do you agree that this is written equal to this? All right, Q into VQ minus VP. But look at Q. Q is negative, right? Q is negative, and VQ minus VP. We found that here. Look at this. Look at this. VP minus VQ is positive. So VQ minus VP is also negative. So what will be the final answer? Positive. Clear? Yeah, positive. Correct. Okay, I hope nobody has any problem with this simple idea. So if UQ minus UP is positive, then sorry, UQ minus UP is positive. So UP minus UQ is negative, right? That's it, right? Similarly, I'm leaving it for you to tell me. Okay, tell me what will be the answer for AB. Then what will be final answer? We can't really say here what they are what do they want to ask, right? Do they want to ask UQ minus UP or UP minus UQ? If we take other way, we'll get opposite answer. I agree, right? So if this is asked in exam, I will request all of you to write it completely like this: UQ minus UP positive and UQ, sorry, UP minus UQ negative. Be on safe side, okay? Right? Okay, next one, UA minus UB, positive or negative? UA minus UB. Hurry up, people. Right? Correct. UB minus UA is negative and UA minus UB positive. Very good. UA minus UB is negative. Tanay, are you sure? Okay, let me do it. Let me do it. Over here, I hope everybody is seeing this. So if I multiply Q with it, okay, but Q is negative. So Q is negative multiplied by positive. So negative into positive is negative. So UB minus UA is negative. All right. Okay, UB minus UA is negative, but UA minus UB is positive. Okay, UA minus UB. Okay, the meeting is still on, is it? Right. That's very strange. I thought the meeting has ended. Frankly, I was about to go. Which one should we consider right both in the exam? Okay, because the question itself doesn't mention. No, Chaitya, for that you'll have to contact school. Okay. Fine. Let's go to C. Let's go to C. And I'm going to take the diagram on new page now. I don't like this. Right. Can't it be an MCQ? It can be MCQ, but if it is like this, there will be big trouble, right? If that's the case, Kodal, if you're getting too confused, you could see the way, in fact, they might not even have written an answer, I suspect. If some answer is given in the book, you follow that. Otherwise, it's fine, really, because it could go both ways, right? So I can't say which one to go with. Okay, C. C answer. Give the sign of work done by field. જો હવે આ સુધરી ગયા. અહીંયા લખે છે work done by field means we have to find work done by electric field. All right. Okay, in moving small charge from small positive charge from Q to P. I hope you all remember this. Work done by system is minus delta U in going from Q to P. So I should be writing UP minus UQ. Okay. Tell me the answer. Hurry up, come on. So that we can end this class. Hurry up, hurry up. Come on. Remember, the charge is positive, right? External electric field, Dhaval. Which external electric field? There is only one electric field. Okay. Well, let's see. Okay. Very bad. Yeah. Okay. So minus Q outside Vp minus Vq, right? It is quite clear that Vp minus Vq is positive, right? And charge Q is also positive this time. So positive into negative is negative. All right. Okay. So final answer of this one is negative. C is negative, right? There is also one more way. Listen to this method. We have to move the small positive charge from Q to P, right? So electric field at this place is like this, and the displacement is in opposite direction, right? I hope everyone understood what I said. It's like this, right? Here is P, here is Q. You are moving this charge like this, but the electric force on the positive charge is in this direction, right? Because charge Q is positive, right? So that's why the work done by this electric force is going to be negative, because these two are in opposite sense. The small charge is test charge, so you don't have to consider its field. So final answer is negative, right? Final answer is negative. Someone still wrote positive. What happened? Sakshi, wrong answer. Think about it. Negative. All right. પછી છે ને બધા આજના ક્લાસીસ પૂરા થઈ જાય પછી શાંતિથી મગજ ઉપર બે ત્રણ વાર બરફ ઘસી અને પાછા આ ક્વેશ્ચન સોલ્વ કરજો. આવડી જશે. કન્ફ્યુઝન થાય એટલે ન આવડે. ઓકે, goodbye everyone. We will end it. We will complete remaining questions tomorrow, or yeah, tomorrow. Okay, okay. Goodbye.